For introduction, background of study, pavement design is the process of determining the most cost-effective mix of pavement layers in terms of both thickness and material type to suit the soft foundation and the total traffic expected over the design life. So, pavement design consists of mainly two parts, which is rigid pavement and flexible pavement. Then, for displaced pavement, the main factors to be considered in the pavement designs are traffic, climate, road geometry, and position of soil and drainage. A displaced pavement is defined by formation of potholes, ruts, cracks, localized depression, and settlement. And type of pavement, which is rigid and flexible, have a pavement distress for each type, which is for rigid, blow-up, corner break, gravity cracking, faulting, joint load, transfer system, deterioration, linear cracking, pop-outs. And therefore, flexible is fatigue cracking, building, block cracking, corrugation and shelving, depression, joint reflection cracking, patching, longitudinal cracking. And therefore, the objective of study for this project is first to study about common asphalt pavement distress, and second to analyze pavement using CAMPAVE software.
Hi, my name is Nurul Ashikin, and I will present about the methodology in this project. This chapter will outline the research methodology that was used for this project. Furthermore, it will describe the information that were chosen to address the problem and fulfill the objective of the studies. So first is overview of CAMPAVE software. CAMPAVE software is a computer package for pavement analysis and design applied to calculate stresses, strain, and deformation in flexible and rigid pavement. More details are shown by the next presenter, which is Nur Najwa, to explain more information about the CAMPAVE software during run according to the project attachment. Next, the fourth picture shows the layer moduli pitch. The picture shows the modulus data of field. The data from project attachment was calculated to get the average of modulus for 100%. And lastly, the last picture, which is show the load information page. And this page are filled in the load information. Then the software are ready to run and give the result. Here is the procedure for CAMPAVE software. So for the first, shows the main page of CAMPAVE software. On this main page, click the file which is in the right circle and click new to go to the general page. Second picture shows the general information page. On general page, fill up the data from the project attachment. Then click OK on the right. So the third picture shows the layer thickness, Poisson ratio, and unit width pitch. The data about the layer thickness and so on are filled based on the project attachment.
As for the CAMPAVE software, this is how to use it. As stated from the methodology, this is step by step how to use the software. First, open the CAMPAVE and click the layer name here, and then it will pop the main menu layer data. After that, go to file here and click new to create the new data file. Okay, after that, as we can see here, the data set 1, if the data set 1 yes, then it's good to go. For the next step, click the general here and input the title for the project. For this project, let's just input group 4. For us, let's input the 1. 1 is mean linear for the type of material, and if we want to, we can choose the damage analysis that we want to use, and for our group we choose 2 with the detailed printout. After that, input the number of layer that we want for in this project, which is 3 layer, and we don't have any z coordinate for analysis, so just input 0 and choose the unit for the project. So we use the standard unit, which is SI. Then click OK. After that, go to the layer here, click the layer part, and we need to input the thickness and the Poisson ratio for our analysis. So in this project, we use 15 for the first layer and 20 cm for the second layer. And for poison ratio, we use 1.8, 1.6, and 1.6. Then click OK. Modulus, click the moduli button here and pick period 1. Okay, after that, we need to input the elastic modulus for each layer. So for layer 1, we do the manual calculation based on the data given. And for the first layer, we got 234,000 and 530. For layer 2, we got 300 and 130 kPa. And for the last layer, we got 338,230 kPa. And after input the data, click OK over here and click one more time OK. After that, go to load here and click here to input the load. But before input the load in here, we need to first go to the main screen here and click on the L graph for load zoom 1. And for CR, we can look at here is 11.48. For CP, is contact pressure, we can look here 2.633. And for dual spacing, we should get 8. And NR or NTT is our alpha layer, so we input 3 and click OK. After that, just save as our project and put the title for our project. Let's just put group 4 and save our project. And when our project has been saved, we can click the exit button here and click the CAN layer over here to get the data. And the data will be something like this. And that's how to use the CANPAVE software. That's all.
Now is for part result analysis. Firstly, this is the table data used in the CANPAVE software, such as the number of layer, degrees of density, the dry density, resilient modulus, and the others. For the value of Poisson ratio, it is being calculated by dividing the principal stress and axial stress. So the Poisson ratio used for the 3 layers being rounded off into 2. Next, after the analysis, the first result produced is the L graph. It shows the value of the contact radius, which is 11.48 centimeters, and the contact pressure is 482.633 kilopascal respectively, while the dual spacing result is 8 centimeters. Other than that, it also shows the diagram of the pavement thickness as the data inserted in the software. After that, the load analysis being run in the software, and this is the final result. This table shows the result of the vertical displacement, stress and principal stress in terms of major, minor and intermediate. The average compressive vertical strain in asphalt layer is 2444.043 and negative 0.0223. While the value of maximum compressive vertical strain at top subgrade is 2840.215 and negative 0.0179. When the pavement layer is subjected to vertical stress, it gets compressed. The compression led to the crushing of the material, so depressions are formed on the pavement surface, which is called as the rutting of pavement.
According to CANPAVE analysis, the result obtained are the maximum tensile strain in the asphalt layer, the average compressive strain in asphalt layer, and the maximum compressive strain at top subgrade. From that value obtained, the allowance for load repetitions to stop rutting and fatigue failure can be predicted by using the transfer equation according to Asphalt Institute. The results from the calculation for the allowance of load repetitions for rutting and fatigue failure are shown in the table above. Moreover, the damage analysis from CANPAVE software is shown as in the table above. The maximum damage ratio from the analysis is 4.565 times 10 to the power of negative 8, and it occurs at the bottom of the layer. In conclusion, it is important to run analysis on existing pavement condition in order to prevent any pavement distress to occur prematurely. CANPAVE software is one of the pavement analysis software that calculates stresses, strains, and deformations in flexible and rigid pavement. From the analysis, rut distress occurs on the asphalt pavement. So, further actions need to be taken to improve the existing pavement condition. The possible causes might be due to poor mix design or improper compaction during road construction. Thus, treatment need to be done to improve the pavement condition.